All right, this video is kind of an add-on here. I'm going to call it Physics Video 1.3b. It's a little bit more with average velocity and average speed, but it shows you how to do two-step problems. This is the last of the learning targets, I believe, in section 1.3. Okay, so here we go. It says, for our first example here, it says that Roy rides his bike 18 miles west in 3 hours, and then he turns and he goes 16 miles east in 4 hours, and we're trying to find his average velocity. Okay, so oops. So what separates this problem from the ones that we had done previously is that there's a change in direction, right? Because before we always did problems where, you know, the object was just moving in a straight line. But here, Roy's riding west, then he turns around and he goes east. Okay, and so what we're trying to do is find the average velocity for the whole trip. So you're going to do the same thing you did before, which is start by writing out what you know. But the problem is that there are two different sort of distances and two different times. So when you get a problem like this, you have to break it up into two, what I'm going to call, for lack of a better term, two chunks. All right, so the first chunk is the part where he's going west. So we're going to call that chunk number 1. All right, and then the second chunk is this part where he's going east, and we will call that chunk number 4. No, that's silly. We'll call it chunk number 2. Sorry, that was a terrible joke. Let's start by writing down what we know. Okay, so for chunk number 1, we know that he's going to go 18 miles west. So that's a measure of how far he went. We'll call that our displacement. It's negative because he went west, negative 18 miles, right? And then it tells you that that took 3 hours. Okay, so if I wanted to, I could find the average velocity just for that chunk, but that's not what we're trying to find. We're trying to find the average velocity for the whole trip. Okay, so let's look now at chunk number 2. In chunk number 2, we know that he's going to go 16 miles east, so his displacement is going to be 16 miles, and for that chunk, the time is 4 hours. All right, so the question wants to know, what's his average velocity? So the equation for average velocity is displacement over time, right? But we're looking for the average velocity for the whole trip. So I've got to use the displacement for the whole trip, right? So the displacement for the whole trip, well, remember in section 1.1 we learned that you can just add your two chunks, right? So we went 18 miles west, and then we went 16 miles east, and as a result we ended up 2 miles west of wherever we started. All right, now we got to take that big mess and divide it by the time. So our time is, well, the first part took 3 hours, the second part took 4 hours, so 3 plus 4 is 7 hours. Grab your calculator, divide it out, and you get negative 0.28. Sorry, I totally don't have my answer written down here. All right, so you get negative 0.29 miles per hour. Okay, so there's our average velocity for the whole trip. All right, now we got to find the average speed for the whole trip. So to find the average speed for the whole trip, average speed is distance over time. Well, remember, your distance is the same as your displacement, but without negatives, right? So up here for chunk number 1, if my displacement's negative 18, then my distance is positive 18. And over here, if my displacement is 16, then my distance is going to be 16, right? So to find the average speed for the whole trip, I'm going to do distance, which is going to be 18 miles for the first chunk, plus 16 miles for the second chunk. Notice it's the same as what I did up here, but without the negatives. And then the time is still 3 hours plus 4 hours. So we end up getting 34 miles in 7 hours. Divide it out, and you get 4.9, 4.85, 4.86, I guess, 4.86 miles per hour. Okay, so there we go. That's how you do that. All right, now, there's one other type of problem. It's basically the same thing, but with a couple extra steps added in. All right, this one was not bad because for both of the chunks, when I wrote the problem, for both chunks, I gave you the displacement and the time, right? Sometimes I won't do that. So let's learn how to solve those. So here's another one that's very similar. We're going to solve it kind of the same way, with kind of an extra step added in, I guess, is probably the easiest way to say it. All right, so this time, Sally drives her car 180 miles north at 60 miles an hour. So that's my chunk number 1. And then she turns around and she goes south at 50 miles an hour for 2 hours. That's chunk number 2. So it looks very similar to what we just did. But the difference is what information I gave you. So let's start, just like we did last time, by writing down what we know. So for chunk number 1, I know that Sally drove 180 miles north. That's the displacement. At 60 miles an hour. Let's see, miles per hour. That's going to be a velocity. Okay. And then for chunk number 2, she went south at 50 miles an hour. So my velocity is going to be negative 50 miles per hour. Negative because she's going south. And my time is 2 hours, right? Okay. So the question wants us to find average velocity. So here's the deal. Average velocity is displacement over time. But the problem is, oh, stupid computer. All right. The problem is that I know the displacement for the first part of the trip, but I don't know it for the second part of the trip. And I know the time for the second part of the trip, but I don't know it for the first part of the trip. Okay? What you cannot do is you cannot, please hear me say this, you cannot take the displacement for the first part of the trip and divide it by the time for the second part of the trip. That doesn't make sense. Okay? So we got to do a little bit of kind of extra calculations. All right? So let me clear up the board here. Let's get rid of some of the red that I just drew. Okay, so here we go. So our problem is this, that we don't know the time for the first part of the trip. So find it. One of the equations we learned is time is displacement over average velocity. So we went 180 miles at 60 miles per hour. That means the time for this part of the trip is 3 hours. Okay? And then similarly, over here, for chunk 2, I don't know my displacement. I don't know how far I went. So let's find it. Displacement is velocity times time. We're going to go negative 50 miles an hour for 2 hours. We're going to go negative 100 miles. Okay? So now that we've done that extra legwork, now we can find our average velocity and our average speed. Okay? So here we go. Average velocity is displacement divided by time. So let's see, the displacement for the whole trip is going to be, well, let's see, 180 miles in the first chunk, negative 100 miles in the second chunk. So my displacement for the whole trip is just 80 miles, right? But I got to divide it by the time for the whole trip, which is 3 hours plus 2 hours, which is 5 hours. Divide it out, and you get 16 miles per hour for your average velocity. Okay. All right, and then finally, we can find our average speed by doing distance over time. So same thing we did before. We're just going to ignore the negative signs and do the same thing. So it becomes 180 miles one way plus 100 miles the other way. Notice I dropped the negative. The time that took was 3 hours for the first chunk, 2 hours for the second chunk. So we went a total of 280 miles in 5 hours. So that's 56 miles per hour for our average speed. Oops. Let's clean that guy up there. All right. So this problem will, well, not this problem, a problem just like this will be on your test. All right. And it's an 8-point problem, okay? So it seems big, but there's a lot going on, right? There's 2 points to figure out what you're missing for the first chunk, 2 points to figure out what you're missing in the second chunk, then 2 points for average velocity, 2 points for average speed, all right? And this historically is one of those problems where people either get it all right or they get it all wrong. So please make sure you know how to do this. This will be on your test. It is something you are expected to know how to do. All right. I can't ask if you have questions because this is a video. All right, I'll see you in class. There you go.